How does the constant K, which is the shape factor, affect the calculation of grain size, and why is it typically taken as 1 for crystals? How does the wavelength of X-rays, lambda, play a crucial role in determining the diffraction pattern and the resulting grain size of a material? Why is B used in the formula as the half-height width of the diffraction peak? And what does it indicate about the material's structural characteristics? How does the diffraction angle theta influence the grain size calculation? And what role does it play in interpreting the diffraction data? What is the significance of using a diffraction curve with low angles versus high angles? And how does the selection depend on the size of the grain? How does the choice of diffraction angle impact the precision and reliability of the grain size estimation? Why is equation 2.2 specifically applicable to materials with a grain size range of 1 to 100 nanometers? And what properties make it suitable for this range of materials? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does this equation help refine the understanding of materials with nanoscale grain sizes, particularly in the context of sodium-ion battery research and other advanced material applications? How does the grain size influence the overall performance of materials, and why is it important to accurately measure and calculate it using X-ray diffraction and related formulas? How does the sharpness of X-ray diffraction (XRD) peaks relate to the crystallinity of a material, and what does a sharper peak indicate about the material's structure? What does a higher intensity of the diffraction peak signify regarding the crystallinity of a material, and how can this be used to assess the quality of the material? How can the lattice parameters of a material be discerned from the shift in the diffraction peaks observed in XRD data, and what information does this provide about the material's structural properties? What does it mean when diffraction peaks shift to a lower angle in an XRD pattern, and how does this indicate a change in the material's lattice parameters? How does the shift of diffraction peaks to higher angles affect the material's lattice parameters, and why does this shift occur? What is the significance of these shifts in diffraction peaks for understanding the physical and chemical properties of the material? How do changes in the diffraction peak position relate to the material's overall stability and performance, particularly in the context of battery materials like sodium-ion batteries? How can these observations be applied in research to optimize the properties of materials for specific applications? How can the analysis of diffraction peak shifts aid in the development of materials with desired characteristics, such as improved conductivity or mechanical strength?